Question 5 states that P is a point K1 in the second quadrant and square root 5 is the radius of this terminal arm. Okay. So question 5.1.1 asks us to calculate the value of K. We see that the value of K is the x-coordinate in this right-angled triangle, right? So we can simply use theorem of Pythagoras. So K squared plus 1 squared will be equal to the square root of 5 squared. This means that K squared is equal to the square root of 5 squared minus 1, making K squared equals to plus or minus 4. Therefore, K is equals to minus 2 since we are in the second quadrant and x is negative. Question 5.2a now says calculate the tan of theta. Well, theta is going to be 1 over negative 2. Okay. The cos of 180 degrees plus theta is a reduction formula. 180 degrees is in the second quadrant and causes negative there. So this becomes negative cos theta. Then from the diagram, you have negative 2 over square root 5, just giving you 2 over square root of 5. Question C says that determine the sine of theta plus 60 degrees. We can see that this is a compound angle, right? And remember, sine is the one that has the expansion that keeps its sign the same on the outside. So expanding will have sine, cos, cos, sine. Then we just need to place in our theta 60 degrees plus theta 60 degrees, right? Then we've already calculated the sine of theta. The cos of 60 degrees is 1/2 and the cos of theta is negative 2 divided by the square root of 5. Sine 60 degrees is square root 3 over 2. Remember, cos 60 degrees and sine 60 degrees are both special angles, and these are values that you should already know. Right, simplifying, we'll have 1 times 1 is 1 divided by 2 times the root of square root 5. Plus, actually we can distribute that into the bracket, making minus 2 times the root 3 divided by 2 root 5. Okay. Now we have the same denominators, so we can just subtract the numerators. However, the question asked us to give this in a specific form. They asked us to write this in the form a plus b divided by the square root of 20. Okay, so in order to do that, I'm going to change 2 back into a square root. So this will give you 1 minus the square root of 4 times the square root of 3 divided by the square root of 4 times the square root of 5. Then we can multiply the contents inside the square root to make it into 1 square root. So 4 times 3 is 12 and 4 times 5 is 20. Okay, and there you go. Question 5.1.3 asks us to calculate the value of tan of 2 theta minus 40 degrees. Right, we've calculated above that tan theta is equals to negative 1/2. So theta will be equals to shift tan of negative 1/2. If you put that into your calculator, you'll get that theta is equals to minus 26.56 degrees. Okay. Then you can write plus k times 180 degrees, k an element of integers, just to make that solution complete. However, we're just going to concentrate on the angle that we found. Substituting that angle back into the given equation and putting this into our calculator will give us an answer of 18.3, as they asked us to correct to 1 decimal place. Question 5.2 is now an identity. Okay, they say prove that cos x plus sine x divided by cos x minus sine x minus cos x minus sine x divided by cos x plus sine x is equals to 2 times the tan of 2x. Okay, Right, so with identities, you always consider the side that has more room of manipulation. In this case, we're going to consider the left-hand side. We can see that we have to subtract two fractions, so we have to find our lowest common denominator, or our LCD, which is simply just the product of the already existing denominators. Okay. If you see here, this is an expansion of a difference of two squares. So this collapses down to cos squared minus sine squared. And this is one of our identities. Cos squared minus sine squared is equals to cos 2x. Now we can multiply the first fraction with the denominator which we don't have. So cos x plus sine x, we're going to multiply with cos x plus sine x, which will give us cos squared x plus 2 cos x sine x plus sine squared x, all divided by cos of 2x. Okay. Same thing with the second fraction, that will give us cos squared x minus 2 cos x sine x minus plus sine squared x divided by cos 2x. Okay. Now the denominators are the same, so if we distribute the minus into the second fraction, you'll get minus cos squared x, which will cancel, and minus sine squared x, which will cancel with the plus sine squared x in the first bracket. Okay. Then you're going to have 2 lots of 2 times cos x times sine x, right? However, 2 times cos x times sine x is sine 2x, right? And now that we have that, this just simplifies down to 2 times tan of 2x, which is equals to the right hand side. And thus you've proved your identity. Okay. Question 5.3 says evaluate using a without using a calculator the sum of a from 38 degrees to 52 degrees of cos squared a. Okay, so now this is integrating the knowledge that you learned from arithmetic sequences in series. Alright, this specific one is most probably going to be an arithmetic sequence since you are given the first and the last term. Okay, so how we're going to set this up is that let's first write out the first 3 terms of the series. Okay, before we do that, let's just remember what the sigma sign states. The sigma sign says that you're going to be taking the sum from the start of the following formula, starting at I and ending at whatever value is written at the top. And the number of terms that you're dealing with is calculated using the end point minus the starting point plus 1. Okay. So for our specific series, the first 3 terms look as follows. You have cos squared 38 degrees plus cos squared 39 degrees plus cos squared 40 degrees plus all the way. Okay. So the first arithmetic sequence formula that we know is Sn is equals to n over 2 divided by n divided by 2 multiplied by 2a plus n minus 1d. However, we don't have a d in this problem, so we're most probably going to have to use the second formula, and we can because we do know the last term. Okay. So now cos squared 38 degrees is our first term and cos squared 52 degrees is our last term. And the number of terms in this series is 52 minus 38 plus 1, which is going to give you 15 terms. Okay, so this is our value of n. Substituting that, squared of 38 degrees plus cos squared 52 degrees. However, when we look at 38 and 52, we see that these two are co-angles, meaning that they add up to 90 degrees. So we can change cos squared 52 degrees into its co-function. Okay, we do that by saying the cos of 90 degrees minus 38 all squared is equal to cos squared 52 degrees, right? This then becomes sine of 38 degrees squared. Okay, now we have an identity inside. We have cos squared theta plus sin squared theta, which is equals to 1. So our answer is just 15/2. Okay, question 6 then asks us to consider the function f of x is equals to minus 2 tan of 3/2x. Okay, so now remember with trigonometric functions, our a value specifically for the tan graph determines the steepness, the b value determines the period of the graph, c is the horizontal shift, and d is the vertical shift. In our specific graph, we don't have any horizontal or vertical shift, we just have a change in period. Okay, so if we divide 180 degrees by 3/2, we get our new period to be 120 degrees. Question number 2 says the point A, which is T2, lies in the graph. Determine the general solution of T. Okay, so now you're going to have 2 is equals to minus 2 tan of 3/2t, then dividing both sides by negative 2 gives you negative 1 is equals to tan of 3/2t. So 3/2t is equals to 180 degrees minus 40 degrees plus k times 120 degrees. This is because tan is negative in the second quadrant. Okay, then dividing through by 3/2, this will give us 90 degrees plus k times 180 degrees, k an element of integers. Okay, or the other quadrant where tan is negative is the fourth quadrant. So you then use your reference angle, you subtract it from 360 degrees since that's the reduction formula in that quadrant, making t being equals to 210 degrees plus k times 180 degrees. Okay. Question 6.3 says we need to plot this graph in the interval of minus 120 and 180. Remember, in order to plot the graph, you need to remember what y is equals to 10x looks like, and it is shown on screen. Just the missing points are 135 degrees minus 1, 225 degrees 1, and 360 degrees. Okay, so we're going to use all of these points. These points I call key points in order to plot our function. Okay. Okay, we've already seen that the period is equals to 120 degrees. So the intervals that we're going to be working with are given by the period divided by 4. So 120 degrees divided by 4 is 30 degrees. Okay, so we're going to consider points every 30 degrees. Then we need to find ourselves a starting point. I usually like to find a 0 point, the origin. So remember, we are working with y is equals to negative 2 tan of 3/2x. So if you substitute 0 degrees into this formula, you'll get tan of 0, which is 0. Okay, so our starting point is simply just going to be 0 degrees 0, which is the origin. Okay. The next thing we need to determine is the asymptotes, right? So the way that we're going to determine the asymptotes is by multiplying the original asymptotes by the inverse of the value of b. Okay, remember b is 3/2, so we are going to multiply by 2/3. Okay, so we're going to multiply all the original asymptotes with 2/3. However, when we look at the interval that they say we must work in, we see that we'll have another asymptote at minus 90 degrees. Okay. However, we need to still multiply that again by 2/3. Okay. So then this will give us our new asymptotes of minus 60 degrees, 60 degrees, and 180 degrees. Okay. This is going to be the position of our new asymptotes. Once we've done that, we need to figure out our key points, and we're going to find our key points using the exact same method that we just did. We're going to multiply the x values, okay, of our key points with 2 over 3, and we're going to multiply the y values by -2, which is the a value in our original equation. Okay, so I'm just going to quickly jot down all the original key points. For the first point, it's going to be -90 degrees minus 2. Then -30 degrees 2. Then 30 degrees minus 2. Then you're going to have 90 degrees 2. 120 degrees 0. 150 degrees minus 2. 210 degrees, and then 210 degrees is outside our interval, so that's where we're going to stop. Okay, so now we have everything that we need in order to plot our graph. Okay, so if you see on the screen, I've already jotted down our intervals going up by 30 degrees, and then now I'm just putting in the asymptotes at -60 degrees, 60 degrees, and 180 degrees. Then you're simply going to plot all of these new points. So -90 degrees 2, 30 degrees 2, 30 degrees minus 2, 90 degrees 2, 180 degrees 0, 150 degrees minus 2, and don't forget your starting point of 0 degrees 0. Okay, so now remember the tan function looks like this. However, we have a less than 0, so our tan function is going to slide to the right. Okay, so you're going to connect the dots, basically just following the shape that indicates that a is negative. Okay. And then that's it, guys. By symmetry, you'll see that at the endpoint of -120, you're going to have a x-intercept the same as at 120, so the graph will just look like that. Then you just label it f of x and you're done. Question 6.4 says use the graph to determine when is f of x going to be greater than or equal to 2. Okay. So we go back to the graph, we see that, okay, the graph is greater than or equal to 2, firstly between -60 degrees and -30 degrees. That's the first time that that condition is met. Second time that that condition is met is between 60 degrees and 90 degrees. Right. So now we just need to write this down in mathematical words. Okay. So 6.4, f of x is greater than or equal to -2 when x is less than or equal to 90 degrees but greater than or equal to 60 degrees, and when x is less than -60 degrees. Actually, above I made a mistake. It's actually supposed to be greater than 60 degrees because remember 60 degrees is an asymptote, so it's not included. Okay, so x is greater than -60 degrees but less than or equal to -30 degrees. That's the two conditions when f of x is going to be greater than or equal to 2. Okay. Question number 6 says determine the transformation of the graph to form the graph of g of x is equals to -2 tan of 3 over 2x plus 60 degrees. Okay, so obviously now we've had a horizontal shift. However, don't be too quick to say that the graph has been shifted to the left by 60 degrees because actually how this equation has been written is it's not taken into account the fact that a hasn't been factored out. So currently this equation is in the following form. However, the correct way to write out the general form for trigonometric equations is as follows. You write that f of x is equals to a times tan of b into x plus c plus d. Okay, so what does this tell you? You need to take out b as a common factor so that you can see what is truly happening to the graph. Okay, so if we take out 3 over 2 as a common factor in our graph of g, we'll be left with x plus 40 degrees. Okay, so then they said describe, so you can write down in words that the graph of f, okay, has been shifted by 40 degrees to the left. Okay, remember it's always the opposite direction to what the sign indicates. Right, so that's the end of question 6. Let's move on to 3D trig in question number 7. Right, in this question we have a pilot that's looking down at some object at point B, and there's a control center at point C. The first question asks you to find AB in terms of H. Okay, so we see that AB is in the triangle ABD, right? So this is a right angle triangle, so we can use normal trig ratios, right? The pilot has an angle of depression of 30 degrees, okay? So which means that if you stand at B and you look up at the pilot, you will have an angle of elevation of 30 degrees, right? So now we need to look at the relationship between 30 degrees AB and H, right? And we see that the relationship between those three variables is sine. So we can say that the sine of 30 degrees is equals to the opposite, which is H, divided by the hypotenuse, which is AB. Multiplying both sides by 8b and then dividing both sides by sine of 30 degrees, you get that AB is equals to H over sine 30 degrees. Sine of 30 degrees is equals to a half, so AB just simply equals to 2H. Okay, the second question asks you to determine the distance between the strange object at B and the control center at C, which is given by the specific equation that they give you. Right, so if we look at BC, okay, we see that it forms part of triangle BDC, okay. However, triangle BDC doesn't have enough information for us to actually work with. But if you look closely, you see that BC also forms part of triangle ABC, okay, and you have an included angle of 2x in that triangle. So this question is set up very nicely to use the cosine rule, okay. So you can state it first of all and then substitute. So in triangle ABC, you have that b squared is equals to ab squared plus ac squared minus 2 times ab times ac times the cos of the included angle. So you'll have 2h squared plus 3h squared minus 2 times 2h times 3h times the cos of 2x. Okay, remember, cos 2x is a double angle, so you most probably have to change that into one of its transformations. Okay, so then we'll have bc squared is equals to 4h squared plus 9h squared minus 4 times 2, 2 times 2 is 4, 4 times 3 is 12, so 12h squared times the cos of 2x. Okay, then we have a common factor of h squared from all of these terms, so taking it out, we'll have h squared into 4 plus 9 minus 12 times cos of 2x. Okay, if we look at our end goal, we see that we have a cos squared. Okay, so which means that we're going to have to change cos 2x into 2 times cos squared x minus 1. Okay, so that's the expansion for cos 2x. Then we simply have to multiply minus 12 into the bracket, giving us minus 24 times cos squared x plus 12. Then bc squared is going to be equals to a squared into 25 minus 24 times the cos of cos squared x. Then taking the square root of both sides, you'll just end up with bc is equals to a root of 25 minus 24 times cos squared x.